Yeah, welcome everyone to Cloud Computing and Big Data, Parallel and Scalable Machine Learning and Deep Learning. Today we have a practical lecture 7.1 of understanding really deep learning techniques in clouds. We have the different facets looking particularly in Amazon, but of course many of the concepts are also available in other cloud vendors like we have seen before in MS Azure, for instance, or also in the Google Cloud. But before we go to the more practicals that nicely connects to lecture 6 and 7 in the course, let us review what we had actually in lecture 7 the last time. And the idea was really in lecture 7 to go one step further. If you remember in lecture 6, we had the idea of doing firstly multi-output perceptrons, a sort of addition to what we learned very early in the course with the perceptron learning model. Then realizing that one neuron, one of these perceptrons, so to speak, is not enough. So what happens if we connect many of those? And the idea was then in lecture 6 already using artificial neural networks. We touched a bit on basically the ideas of creating non-linearities, then in the activation functions with rectified linear units to really catch the non-linearities in data understanding and learning. And then basically we ended on a notion of saying, okay, what is the added value now of deep learning? And we said, well, it's not much more hidden layers. The idea is having very specialized layers that we then looked in a particular example of convolutional neural networks. So hence today we will also talk about the material of lecture 6 again. But of course, lecture 7 then was also the idea to deepen the understanding a bit of lecture 6 and to really think more broader in scale. So in one view that we had there was the application where we said like, okay, we have here, for instance, satellite images that we had the last time. And you can imagine satellite data gets ever better in terms of resolutions and in different bands. We call that basically different spectral bands, hyperspectral data sets, multispectral data sets, reaching basically within the Earth, also then creating different dimensions. So you don't only see what you here basically see from the top of the satellite, of the top of the world, you basically look a little bit also deeper in what materials even are basically there. You can actually differentiate them based also on this different spectral channels that you have there. But I don't want to go too much into detail in remote sensing. There are others here at the university that actually teaching this quite nicely. Gabriel Cavallaro, for instance, is a professor I work with a lot, so he can teach you much more in this regard. The key message to take away, I think, however, is this is big data, right? So this is something where when you want to do satellite image analysis, like here, for instance, understanding just patches perhaps. So is it a beach area? Is it a forest area? And so on. You're quickly at the end of the Google Collaboratory, right? Alone loading this up all with HTTP somewhere in the cloud could be already quite some effort, and it's big data. And then you have basically just one GPU. And the understanding really why one GPU is not enough is also something that we will discuss today. Of course, not completely at the scale, but you can imagine that with big data, the idea comes quickly that we need more processing power. Not only storage is here the problem, but we want to really analyze these different data throughout the different epochs. You have learned that in lecture 6 as well, and lecture 7 that we go with different batch sizes through all these epochs and then learn from data. Now, hence the idea is using different nodes, right, with GPUs. And you have seen last time one example here where we use a residual network, a 50 here, for instance, a ResNet 50 for deep learning. In this recognition, we published this, and you can have some details here basically in this paper. But in a way, it's a very similar architecture we have seen also in lecture 7 on the more higher level idea of understanding this feature learning concept before we then go to the fully connected layer at the end, where we then add some probabilities to the different classes. In other words, instead of car, truck, van, we are interested in, is it a forest area, is it a beach area, agriculture and whatnot. However, the key idea, of course, then going to the cloud or using high performance computing, it's basically equivalent, the idea of scale out, as we have learned with the earlier HD Insight cluster of your assignment 1, right? But this was a different technology. It was based on MapReduce. It was in the MS Azure cloud. But the idea of scalability is now coming back to us also with this particular applications in deep learning. Because if you really want to have cutting edge deep learning models, and what we have today is again a convolutional neural network, which is rather simple for character recognition again, it's very different than the ones we have really in research and engineering, those which are cutting edge. And you see how that works is basically here in this interesting diagram where we have a so-called speed up of the training of such a deep learning network. So we basically take the signal, we use in the supervised setup then the signal and understand are we correct or not correct, and then we update the weights backwards using specific techniques of backpropagation of error, and then repeat, right? Batch size by batch size, epoch by epoch. So in this respect, of course, we are interested on keeping the accuracy. So you see here more and more nodes added. That means more speed up possible, but we wouldn't do the job here with using 96 GPUs if we get worst performance, right? So hence, for us as machine learners and deep learners, still the accuracy is important. There's no point in speeding up the learning if you really have, let's say, terrible results learning from it, just to be faster. Hence, there's a certain trade-off of this, where at some point in time, we have seen also in lecture 7 are limits. We call it the trouble of large batch sizes, for instance. Otherwise, you would say we can learn any data basically in any speed, because today we have, of course, thousands of GPUs in our HPC machines, thousands of GPUs in the clouds, but it's not true that we can use them all directly for deep learning, right? So there's certain limits. Of course, one GPU is mostly not enough, but then using thousands of GPUs is also not that simple because there's some technical limits in this. However, we also learned last time, apart from this problem of the, let's say, large, basically batch sizes versus distributed training that you have, that we also published here, for instance, with Marcel Ach in one paper and so on, when you want to know more about this. We learned that there's the Amazon Web Services as one example last time. And here the message goes that similar ideas using virtualization with the AWS AMIs, there are similar concepts also in MS Azure. There are similar concepts in the Google Cloud. Now, we have also the SageMaker Studio the last time, which means we shift the focus from so-called virtualization, infrastructure as a service, let's say, level of a, basically cloud service, to the software as a service level. Some people call that a fully managed solution, right? So here we have to steer much more on our own, how we connect, how we do distributed machine learning at scale and so on. While basically here in the SageMaker Studio, we have a whole, let's say, nice area, which is basically extracting a little bit from the complexities low level. You see that also nicely here. Here we have the Amazon EC2. We have to pick specific resources and then connect to the AWS deep learning AMIs we pick, and then want to maybe do scaling. Then using different of those together would mean much more work. I come to these technologies, so I don't want to talk much more about this and want to rather demonstrate a couple of things. Obviously, in the light of the time, is 40 minutes for part 1. And for part 2, I can't go in all the details. However, let's have a little bit more practical discussion. And the idea of today is really that we start a little bit with what we already know. So I will create an AMI with you here that you can use normally then for machine learning. And then we go back to our idea of the handwritten character recognition with MNIST that we have already known from lecture 6 and so on. However, here I will make certain points and connections again to the mathematical building blocks in machine learning. You remember we had this in lecture 3.1. There we used logistic regression, but I wanted to show you that the mathematical building blocks, of course, have relevance not only for regression techniques, but also for artificial neural networks. And as we will later see then in the second part of this today, it has also relevance for deep learning, right? So this is sort of the mathematical foundation, how machine learning and deep learning works, and we will make a case for it. Practically, I then switch the demonstration from the AMIs quickly to the AWS SageMaker service. And then in the second part, we basically want to understand a little bit limits. So we will go and see, okay, we have now convolutional neural networks. If you remember, lots of more parameters to train. So what's the role here of the tools? So we have the AWS SageMaker Studio Lab that you have also in your assignment versus the AWS SageMaker Service. Then we're gonna use a little bit the SageMaker Studio essentially for deep learning tasks, and we'll also understand now that having just perhaps CPUs in an instance from SageMaker Studio that I will create with you is not enough, right? Hence the idea that we established conceptually in lecture 6 and lecture 7, we need GPUs. Hence the second lecture is called GPUs in Clouds. And the beauty is that our AWS SageMaker Studio Lab really that you use in your assignment offers us at least a little bit of time of GPUs that I can then show in terms of really understanding why the training is much faster. We do this with more or less toy problems here with the MNIST character recognition. The takeaway the message that, of course, in orders of magnitudes, this is a more impact when you train something like that just was alluding to remote sensing networks, autoencoders we talked briefly about in lecture 7, and the cutting edge transformer models perhaps as well, where then basically much of more GPU power is really needed. We end this today a little bit with the idea of having then to choose different hyperparameters. So it's options for us as humans. And of course, this is alluding to one of the later lecture, as you already know, AutoML techniques, hyperparameter optimization, systematically performed. But some of the hyperparameters is also something you are doing in assignment 2, really. And that's why we also touch base a little bit on it. We don't solve here everything what you do in your assignment, obviously, but it gives you a kind of indicator where to change things and so on. Hence, this lecture is highly relevant for your assignment 2. So let's go a little bit more into the practicalities. So we have the artificial neural networks. You know by now what that is. That is basically we established in lecture 6 already, and now in lecture 7 we looked really under the hood a little bit and have understood how that works. Now, when you want to do this, let's say in Amazon, we learned already that there's this interesting AMI, right? So basically, let's go to the practical demonstration a little bit. I'm here in the Amazon console, basically the main entry point, and you have all your services here. By now, you have seen that already a little bit. And I would pick here in the Amazon world something which is called the EC2, right? The Elastic Computing Cloud. We have discussed this already, and take away the message that before you do anything, we also discussed that we want to have this key pairs, right, created. And you know a little bit that this key pair here is something that you know we had already created, so I can nicely use this, but it's limited to Ohio. Hence, the notebooks, the AMIs we're going to create today is really something where we should stay in the Ohio domain. The reason why I'm saying this is, of course, when you come back to the slide briefly, usually you would create this AMI instance. It would run here somewhere with the deep learning packages we want. Hence, it should be TensorFlow, PyTorch. I come to that in a moment. But it is running all the time. And I want to connect to it, of course, from my different, let's say, clients. It could be a mobile Xterm SSH client installed on my laptop or my desktop PC. But I need these key pairs in order to use a public-private key pair, if you remember, that we had in previous lectures to connect to it. Hence, when we create such an instance in virtualization, then of course here we also need this key pair to really access it then once we logged out. So let's see how that looks like. We firstly can see that there's a certain set of images here available that you know basically gives us also an AMI catalog where you see lots of different of those. And can choose from the different, let's say, you know, filters. There's a marketplace with having preparations of AMIs. So this is, of course, nice, as we learned in lecture 4 with virtualization, that you have pre-installed software already in these images, and you create them again and again out of these images. And the idea how Amazon is doing it is basically the same. Hence, now when we think about all of these different images, we are interested in Linux, yes, perhaps, but we also want specific tools like PyTorch for deep learning, right? Because that's something what is our original aim here to do. Hence, when we now look, there's this interesting AWS deep learning AMIs that we can create, and we talked a little bit about it. So we basically want to search maybe for deep learning to find some, and then we will see a little bit the limitations of it, because if you really want to do this in practice, you need GPUs and would then go perhaps to something like a P3 instance. But of course, this already costs, right? There are 8 NVIDIA for your 100. With this, you can already do something. But of course, here for the demonstration of the free tier that we basically are in here as an example, we don't have that. So the idea is also to think about, also when we come to the notebooks later, that this is always very related. And in a way, of course, what I now will demonstrate a little bit is already captured on the slides. You know the game with a practical lecture, we hop a little bit up and down, right? So you will see when we now perhaps use here this, idea of searching, as I was alluding to, we thought maybe today we want to do deep learning, but of course I can have any other, let's say, any other AMI as well that might be interesting for us using normal Linux or other software services, which might be quite nice for us. So as we see here, similar on the let's say slides here, we have firstly the idea that you have this different packages, right? So this is something we know, we already learned. For instance, here you have a Ubuntu Linux distribution with the GPUs ready for TensorFlow, right? With NVIDIA drivers that is already pre-configured to run really on a GPU instance. Then we have the Amazon Linux, a very specific type of Linux distribution, which has then PyTorch, for instance, 2.3, also having NVIDIA drivers pre-installed. So here we really save the effort of installing PyTorch, of bringing that together with all the underlying NVIDIA drivers. And in the past, there was really much more that you could see there. So basically, when we talk about NVIDIA, quickly about Nickel in library, let's just basically doing neural networks on steroids, so really fast, but also having CUDA, for instance, as the, let's say, programming language for NVIDIA GPUs. So hence, a lot of things which you as a user have to streamline. If you do a blank, let's say, image just of Linux, and then you want to install these different softwares, you have to make sure that all the underlying libraries and so on fit to the hardware accelerator that you have. Of course, NVIDIA is a de facto standard, I would say, in the moment. So many people have NVIDIA cards, many HPC and clouds have NVIDIA cards, but this is also in a momentum of changing. So more and more we see also AMD, for instance, in the Lumi supercomputer, for instance, coming up to the horizon, and Intel is also not far away. So in this sense, this is a little bit the first you have to think about. So we have a certain tool set. We want to have PyTorch or TensorFlow. If you remember, we had also Keras. Keras is now in the distribution of TensorFlow, and many of the examples I have today, and basically also in the last couple of lectures, were based on Keras. Keras is now part of the TensorFlow distribution. And now when we basically pick one, and in the moment it doesn't really matter which one we pick, I maybe pick just maybe the first one we have here with deep learning and PyTorch. That is something where you first look at. Of course, just me briefly just come to this ARM idea. You see some of them are already also thinking about other, let's say, CPU architectures, a RISC design, for instance, here, which is in the ARM processor, let's say, family, which is a little bit more, let's say, lightweight and for energy efficiency. Also, ARM processors we see more and more. Initially, also basically only considered more for, let's say, handheld devices or your phones and so on. But we also see them getting more and more into the mainstream of bigger systems, really. And one idea is, of course, that they're more cost efficient in a way for some of the tasks. So coming then back to the idea of choosing one, we will select here maybe just this NVIDIA AMI GPU PyTorch on Amazon, and they're all very similar, right? So I mean, for us, important is now, is my Python code in the using PyTorch, or is it using TensorFlow essentially, right? This is the two major streams you have to basically differentiate from. And yeah, when you do this, you basically have now selected this particular idea of using one of these vendors, and can then basically switch and launch the instance with AMI. So that this would be then the next steps, where we then have to create a couple of things here. Firstly, you can imagine, and I have that again as one of the slides, of course, costs, right? So, and here be careful, think about when you do this in a sense and want to try it out yourself, you can do this, but without swiping the credit card, you're very quickly in the so-called free tier. We discussed this in one of the earlier lectures. And the free tier here is the T2 micro. And you see already with 1 GB memory, the performance, the architecture, the cost already alluding to that this is a resource which might be not perfectly suited for deep learning. Hence, the point was here, if you really want to do this in your company, in your startup, just think more about P3 or even other larger resources, which are, let's say, more generations of GPUs which are more newer, like A100s, and Hopper cards is also, of course, the latest, greatest generation. But then you can imagine when you come again to the AWS EC2 pricing, go there and pay the price for it, right? Then we are far off from what you see here in terms of price, which is really almost nothing. And as I said, here now we even talk about the free tier for certain hours. So there's some limitations, of course. Hence, we pick here the instance to T2 micro. It says also free tier eligible. So this would be, of course, one of the key things to think about. We talked about the key pair. Also, there's no surprise. We have our previous key pair that we had created there. So that is also clear. And of course, we should give them all a sort of name. Let's pick the one that I actually used here, just for some consistency. But in the way it really doesn't matter. You can name it as you want. You can also have different numbers of instances here. And then basically we are in the regime of just creating, let's say, AMI instance or instance deep learning, something like this, or CCBD instance, and we call it DL, deep learning. Nicely now in the newer versions, this wasn't there 3 years ago or something like this. In the last couple of years, it really improved more and more that you have nice summaries. You can create now automatically more instances, which of course is again bringing in the idea of scaling up, scaling down. You want to maybe do auto scaling, right? If they're not really used, we better shut them down because otherwise we always pay. Now with the idea of having T2 micro ones, it's not really money, and of course it's even free in the beginning. But if you are in a company, again, think about that you would use P3 resources maybe that are really costly. And this is really all in a way which is a general modus operandi of doing this. There are some network elements. Of course, allow SSH traffic is something you should say yes, because you want to have usually your SSH key connecting to it. And then, you know, there are a couple of storages that you can connect to and so on. But in the moment, we think, okay, that's all what we want to know. Let's launch an instance and see what happens. So in the meantime, I follow suit a little bit with the slides, which captures the same idea I think I presented. There should be nothing which is now very, you know, different. Just that, of course, you have this the difference between the image, right? So that you have an AMI, and when you really launch this, then you have an instance. But of course, the AMI is something that is available, so you can create not only one instance here, or you can copy an instance when you may have maybe done already some quite nice work on the AMI one. For example, some codes are there already, have learned something, and you want to give this to your colleagues to perform maybe transfer learning on the same codes or on the same models you have already generated. You can nicely copy the instances. Essentially, much of the things you have learned in lecture 4, using virtualization, using this image idea and the instances of image to really make it easier to work with software in that regard. And this is, of course, nice. Still, take away the message. It's really IAAS level, infrastructure as a service level. So here we don't really talk about Jupyter notebooks, for instance, no really nice web interface. We are here much more on the lower level that you see here also on the bottom right by really going with SSH into this, using your key pair then to essentially connect to this instance. And then you are in the command line interface, as we call it, the CLI, once it is running. So you see, successfully initiated the launch of the instance. Usually you have also notifications here that show you what's happening. Then we basically can go here and click on it. We have the instances then there that have been created, and have here the state running. This is of course something, again, you have to see that sometimes this is pending, right? So you have to wait until this is really running, and this is an important part of it, right? So let's go more into the details here when we have this kind of idea of what is it now, what we're running here. We have a different IP address and so on, so we can connect to it with EC2 with our key. We see a little bit here again the AMI name, again what we also used from the drop down. Of course, it's what we wanted. We wanted to have PyTorch here for an example. We have our key pair assigned. So this is now nice up and running and somewhere on the cloud available. And there we can also basically have now the idea of thinking, I can use my SSH client to really connect. And with this, you of course have a nice idea to use that then with your own Python codes. You have the libraries already there. And this is a very nice, overview for those which are not really want to install all of that themselves. You see already NVIDIA drivers here in specific versions, CUDA versions, as I was alluding to. CUDA is how you program GPUs from NVIDIA. There's a specific version. So all of that is already streamlined to be used and usually works quite well. I will not demonstrate this. It's just running a Python script anyway. But you see already, for a fully managed experience, check out Amazon SageMaker, right? So they say also, if you're not really like the IAAS approach, then maybe the SAAS is more good for you, especially if you're maybe more a machine learner than really some computer scientist, right? And you have, of course, more different options here that I here and there actually had also on the slides. Let's go through some status overview. You have also the idea of monitoring the utilization of the CPUs, of course, which would be also interesting to understand if you have GPUs, for instance, and so on and so on. So storages and so on. And you can also connect to it. This is here basically just, let's say, a client which is inherent here now in the in the browser, really, that you can directly use to connect. And then essentially you basically are inside the instance and can do already something. You maybe use already your Python scripts to get them, learn them, and so on. The more practical way, I think, usually is not like this, what I now demonstrate. I mean, we're here basically now in the domain of Amazon. So host name -f would be the command to see a little bit where you are. So you have a specific IP in the US East and compute internal. So this means we are now logged in. I didn't have to provide the key because we are in the Amazon console itself, right? If you now, and this would be much more production usage, if you now would have your own SSH client, you will use your own key. So, but this is really, I mean, the main message I wanted to leave you on the table here, that creating an AMI is really super trivial. Also exit here and log out just to properly finish all of that. And our idea is, of course, to move a bit ahead and also think about machine learning now. And with this, I wanted to just bring you again also to some practical ideas how we connect now to the mathematical building blocks. Now, remember, lecture 3.1 was talking about it. We have this, data training examples. Here's a supervised version with the labels. Then this is derived from some probability distribution on the data we assume, so from the same problem domain if you want. And then, of course, we're searching with a learning algorithm over time, going through all the hypothesis sets that we have. So the tool sets we have basically that we use together with our skill set of saying, is it artificial neural networks? Is it support vector machines? Is it a convolutional network? And then I use the learning algorithm that goes with it, SVMs, for instance, quadratic programming or neural networks with backpropagation. And over time, using these training examples, I come to something which is the G, the final hypothesis, picking one of those, and that hopefully approximates F well. F is the unknown target function, something that created these examples that we would probably never know, because that is what we sort of want to learn. But what we really want to learn is basically then a sort of unknown target distribution, because we know we have always noise in the data. This was the example I put earlier with, movie rental. Sometimes, you have the same movie X goes in, but you have different Y's out, which is not anymore a function essentially. Hence, the same building blocks apply. So we, instead of picking now logistic regression like we did in, lecture 3.1, and we use it with the HD Insight cluster, the same mathematical building blocks now are for the hypothesis set here in this lecture and lecture, let's say the second part of this lecture now. So here we start now in saying the hypothesis I have is a 2 hidden layer network. That is basically this one we want to use from lecture 6. I picked this out of my skill set. I have it there. And maybe later I can also experiment with deep learning, but now I use this as a hypothesis and see how well we're doing. The data set you already know, so I would like to go ahead. I mean, that is the MNIST you already know, and let's move a little bit into the AWS SageMaker domain. They're a little bit different. You know that by now, I hope, right? So this is also part of your assignment to understand a little bit the differences. So when we go back to the home of the console here, what we should see now is a little bit the Amazon SageMaker, and also take away the message that the instance is still running. I was just logging out, right? But if you go to the instances, they're still running. So in production, you also should consider to then maybe, essentially, deactivate this instance, because otherwise you continue with costs. Now for us, we leave it here in. So this is something where we now want to see a little bit how that works. We have to first think a little bit about domains where you want to create, let's say, an instance of this with the Amazon SageMaker Studio. This is something where we want to create a notebook instance. So basically a much more managed appliance of doing this. And we have this here with the idea of creating a notebook very simply in the SageMaker Studio environment when we go there. So, but this comes also with some new interesting ideas. We see this here in the Jupyter Lab in SageMaker Studio. So almost like the slides now, you see I have already created here basically this notebook just to save time to stay in the 40 minutes. This will take a couple of minutes usually to create, and I captured this a little bit on the slides here. You see it's lots of pending time in the beginning before these notebooks are then really usable, right? And then in this regard, I also want to then open the Jupyter. Now, what you directly see is, in a way, I don't pick necessarily here very low-level options. When you create the notebook instance, what I usually do is a name, and what I did is basically having here the Amazon SageMaker execution role to be created. There needs to be one specific role to be created, but this is very streamlined. You see also we use a T3 medium, which are CPUs, and I make a point of it in a moment when we execute some of our services, but it's still machine learning. So we expect that this should still work quite nice. So let me go back to the Amazon service here, the notebook instance that we have here. And then I want to open this maybe in Jupyter, expecting that hopefully there should be now a Jupyter notebook, starting with, basically the location here. And you would also see, no surprise, we have here already some of our scripts that are basically should be familiar to you, not only because they have been substance of lecture 6, they are also now, of course, part of your assignment 2. We start here with the data understanding maybe. So this is something where now the point is here in demonstrating that just for you that you always have to pick the right kernel, right? So this is also something, I noted this a little bit on the slides, it's important. When you do this, you see here the kernel is idle. Make sure that you have the right kernel here. TensorFlow speaks for itself, so we can have Keras and TensorFlow from these ideas. And here, this is also no big, let's say, surprise now that we repeat some of the things that you see on the slides. You see here and there some differences maybe in the execution than from the slides, depending on which operation of TensorFlow, which version. But the key message is really also what we had in lecture 6, what we had in lecture 7 now. Again, here and there from the source code. Here we use the MNIST, loading the data, which is part already of the Keras distribution nicely. So this is an example where we don't really have to upload the data, but in production, of course, you have now to think about how you get the data over, right, to the cloud provider. And it's also something we discuss also a bit later in the course when we then talk and come back to big data, how you would do that in production. We have here the test set and the training set, as we had also in the slides about MNIST, 60,000 ones of the training set, 10,000 the test set, 28 by 28 pixels. And Y is our label, right? So telling us it's a 0, a 9, a 6 or something. We also wanted to plot this to understand this 2D behavior, right? Which is important to later on differentiate between deep learning and the artificial neural networks we do now. And you see here we have really 26 by 26 pixel in the grayscale, showing us now really the digits. So this is something where then when we have this, we kind of really nicely see that this is something where we can directly see that there might be some connection of the neighborhood, right, as we also discussed before. So this is not time consuming. This is data exploration, coming back to the CRISP DM you have learned early in the course. You hopefully remember. From the kernel perspective, you can, restart clear output. That is also usually never a problem. You see here kernel created. You always should, of course, wait then that here that really the kernel is then ready, right? And now kernel idle. That sounds good, and you can execute it again. So we stop here, and the way to really properly close and halt would be this. You see, leave page, and you see here it's not anymore running, right? So these are still running because it's also for us important to stay a little bit in time of the lecture here. So I go to the artificial neural network one, which of course we now expect should be a little bit more elaborate, right? So that is the one, if you remember now, we picked as our hypothesis set in the mathematical building blocks, and say we want to have now the artificial neural networks, 2 hidden layers. We wait a little bit here so that TensorFlow has everything, let's say, loaded properly. We have still the same data that we just inspected with basically the MNIST data. We have to massage it, if you remember a little bit from lecture 6. Massage in the sense of, we were reshaping the whole, let's say, 2D setup into one long vector. That's what's happening here in the reshape. And then, of course, we had also to normalize it for mathematical convenience, because we will play a lot with the values that you have there. So hence, to prevent, let's say, out of bound in terms of the capacities of the different variables, we really normalize it here so that the values become much more mathematical friendly. And with this, we then have the first model here. You see it's a sequential model from Keras. We add a dense layer and another dense layer, hence 2 hidden layers in the traditional sense of everything is connected to everything, making it a typical, let's say, feed-forward artificial neural network, and some other activation function elements. So these are already going to the domain of hyperparameters, right? What you have to change here and there in your assignment. So you see a little bit the idea of a softmax at the end as activation function, because then that's what we said at the end. It's just about probabilities, right? But in the first layer, we don't have that. So we don't need the probabilities. We have a nonlinear activation function, this rectified linear unit. So this is just a class definition here, or a definition of a model if you want much more. And here with fit, it's now starting to be interesting. So when we go now, you basically see here, no CUDA capable device is detected, alarm bells, okay, no GPU, right? And that should be now an eye-opening experience for you. Also, when you see in the assignment switching from CPU to GPU. We see now here that the training is done, and also the loss and the accuracy is something somehow that we remembered, right, from lecture 6, where we said it's already quite good as an artificial neural network with 2 layers. And it does all the epochs we defined here. And, you know, going through it 6 from 10, it's still, you see, the computational complexity in a way makes it sort of, yeah, a little bit slow, right? We say for such a toy data set, it was a very simple learning model. In a way, simple, you know, has to be carefully stated here. In contrast, I mean for the CNN that we will do later. But you see here, that's what we got, an accuracy of quite well performance at the end. And of course, we want to evaluate this really with a test set we've never seen, and then come to an error which is, you know, very much assembling than the accuracy we had also before. However, this was really the learning experience I would like to draw attention now, right? So this took quite some time and is of course something reviewing in our next part. And just at the close, I think I will go here now through all the slides you have seen, the model we have executed. And we basically are now there saying, okay, it was working with a neural network. It was sort of very slow, but it did the job and we got the accuracy out, but for a very little toy problem. So you can imagine coming back to remote sensing now, satellite data, maybe doing 100 epochs or so through the data, or even, you know, basically batch sizes which are quite large and we have lots of GPUs in. You can imagine that this epoch we have seen just now and the progress, this would be taking substantial time. Hence, what comes to the rescue is then, of course, our second part of the lecture when we want to use GPUs. And the reason why that is, you see again here, the beginning was multi-output perceptrons we had in lecture 6, for instance. I didn't demonstrate it here in the sake of time, but then the artificial neural network with 2 layers here with 20 epochs. I didn't do the 20 epochs, and there's also another idea that we have some other part of the script changed. But you see the regime of having, let's say, an accuracy which is around 95 to 97% when we want to do better. The reason why this was already quite slow is, you know, the training parameters were, you know, already 118,000. So there's weights that need to be trained, plus the biases that are, you know, inherent as we learn from the perceptron. Hence, you can imagine what we will continue after a short break. What is now the world of GPUs giving us, and especially in the light of deep learning? We will still, however, we'll come back also to some of the aspects of machine learning we have just seen today. And of course, in your assignment, you will understand the difference between CPUs and GPUs also yourself. So we break here for 10 minutes and come back then to part 2.